Good evening, everyone. So let's start. Today we are going to discuss two more data types, that is tuple and dictionary. Okay, and after this, we will discuss about functions. It is another concept in any programming language, right? Now, okay, just please let me know if I'm audible. First one, we are going to discuss about tuples. Now, tuple is a data type which is immutable, right? You cannot change the value of a tuple. See, how to create a tuple. So I have variable in my tuple. So this is how you can create an empty tuple. And one more option is, see if I will type my tuple, then the data type of this particular variable is tuple, right? Now create a tuple with some values. So as tuple is immutable, right? You cannot change a value of a tuple. So you cannot insert or delete a particular value from a tuple, right? Once a tuple is created, you cannot insert a value or you cannot change a value. If I will try to just change the index number 1 from 2 to suppose 200, right? See, we will get an error, right? And the error is tuple object does not support item assignment. Means we cannot assign a new item to a tuple, right? Okay. Now these are the basic functions we have seen. Okay. So there are only few functions which works with tuple, right? Because as tuple is immutable, so there are no function to change a value or add new value or delete a value. Okay. Now, so you have a tuple. Okay. So let me know if I will perform tuple. Let me take the indexing first. Tuple 4 dot append, and I want to insert 200. Will I get an error or it will be okay? This particular code will run. Any guess? Okay, yes. There will be no error. Okay. See, this is how a tuple will be created same as a list, right? But you can observe that the boundary of the tuple is closed. In list, in the case of list, we have seen that this boundary was open. See, this is a list and the boundaries are open. But in tuple, the boundaries are strictly closed. It means that you cannot add, remove, or do operations in tuple, right? Okay. See, at index number 4, tuple is pointing to a list, right? So we are free to change the values of this list. We can append, delete, or update the values of a list, right? We can do changes in this list, but we cannot change the value of this index 4. What is the type of data this index 4 is holding? This index 4 is holding a list, right? We cannot change that. We cannot change this list to an integer, right? We cannot say that uh, we cannot do something like that. This is not allowed. My tuple index 4 equal to 200. We cannot do that, right? See, if I will run this one, there will be no error. So there will be no error, right? And the value 200 is appended, right? But if I will try to update the index 4 to some other integer type, in this case, I was trying to update the list, right? The nested list. But in this case, I am trying to update the tuple, which is not allowed, right? So, okay. So in the first, this is the memory mapping. This is how the values are created, right? And now we have appended a new value in the list, which is allowed, right? Which is legal and allowed. But after that, when we try to update the value of a tuple, it will throw an error, right? We cannot change the value of a tuple. We can change the value of a list. If there is somewhere dictionary inside there, we can change that, right? But we cannot change the value of a tuple. Okay. So there are some of the basic functions we have seen. To create a copy, we have to use my tuple dot copy, right? Now this copy doesn't this copy doesn't work with tuple. Okay. See, if I will try to run this one, I will get an error. Now why? So okay, suppose what we are trying to do. Let me take a simple tuple. Okay. So we have seen that how dot copy works, right? It will create the copy of each and every value inside the memory and insert that data, right? But in case of tuple, if a tuple is immutable, we cannot insert or change a value inside a tuple, right? So what we are trying to do here, we are trying to create a my tuple copy, a new tuple. And what we are trying to do, we are trying to insert the values of my tuple one by one, which is not allowed because tuple is immutable, right? Instead of this, if you will do just a simple assignment, right? Okay, first the tuple was created, then again a my tuple, your new variable will be created, which will be pointing to the same memory location, right? So see, there are the only limited operations allowed with a tuple, right? It is so there are some aims to create these types of data types. While using list, we have seen that list is created. We use list to hold multiple values of multiple data types and perform operation, different operations, all that. But the aim of creating a tuple is to store a constant data which cannot be changed during your program, right? So there is not a meaning of creating a tuple where you want to copy some other values, right? If you want to perform copy, create a list, create a dictionary, not a tuple, right? If you want some constant value, suppose if you want to store a student's result, right? Marks of different value, marks, or if you want to store some bank data, credentials, some user credentials, then use tuple, because those user you can you will protect those user credentials from being accidentally changing in your code, right? Now, so copy doesn't work. Count and index. So count and index, that works with tuple. Actually, count and index works with every type of iterables. Okay, so we have this one. Let me perform the count. My tuple dot index of suppose 2. So it will find me the index of 2. That's it, right? That will be 1. Okay. If I will provide something like 3, it will throw an error, value not found. In case of index, right, there are two types of, you can say, syntax to your tuple variable or any type of variable, a list variable or tuple variable dot index and value to search. Right. This is one operation. Another one we have the tuple variable insert, sorry, index your value, and there is some offset. Now, what is this offset? 2 is there in the tuple, right? But I am getting an error. X not in tuple. We are finding some value X which is not in tuple. If I will provide a 2 at the last, we will get a value. So what is this offset? This other than offset, let's call it a start. This start will define from where to start looking for that value. We are telling the index to search for 2 after index number 3, right? We are asking for the index to search the value after index number 3. It will only search this much, right? Not from the beginning. Okay, so that is an offset or a start, whatever you can call it, right? Okay. Other than that, we have count. So count is also available for different types of iterable. We have count the occurrence of 2 and we have value 2, right? And count the occurrence of 100, and in this case we won't get an error, right? We have seen this earlier, right? Index throws an error if no values will be found, but count will provide you answer 0, right? Only this, we have these two legal operations with tuple. We have assignment operation with tuple, right? Now there is one more thing, one more concept which is known as concatenation. Suppose I have a string with name hello. I have a string 2 name world, right? I want to create a string 3 and I want the value of this string 3 to be the combined value of string 1 and string 2, the combined value. Okay? In this case, you can easily do that with the, yeah, by concatenation. This plus operator is not here to do an integer or numerical addition, right? It will add hello with world and put that inside my string 3. See how this will work. Okay, so we have a hello, we have a world, then a my string 3 will be created with a combined value of hello world, right? If I will print my string 3, it will print hello world. So there is no space in between. So let me concatenate one more string in between, and let's put a string between, a space in between, right? So it will provide a space. So it is not compulsory to only concatenate string variables. You can directly concatenate some other string like this, okay, using double quotes or triple quote strings. Okay. Uh, So the same thing goes with tuple. I have my tuple with some values. I have my tuple 2 with some values like 1, 2, 2, hello, right? I want my tuple 3 to be created as concatenated value of my tuple 1 plus my tuple 2, right? And it is perfectly legal. Legal means it won't throw any error, right? We have a concatenated tuple. Okay. Now, instead of creating a third variable, you can also assign to the my tuple 2 again. There will be no problem with that, right? See how it will work. If you will assign the concatenated value again to the same variable, my tuple 1, my tuple 2. Now, what it will do, your Python will do, it will concatenate tuple 1 and tuple 2, and the final result will be stored inside tuple 1, but in some other memory location, right? See, oh sorry, we are storing it in tuple 2. So a new tuple will be created with some other memory location, and the values were stored there, right? The concatenated value are stored there. So this is the concept of concatenation, adding two strings or two similar data types. In this case, we have tuple. Same thing goes with the list. You can perform concatenation with list, but not with dictionary type. We will see why not. So if you have a list, values 1 to 3, you have a my list with some values 100 and 200, and my list, my list plus my list, and it is perfectly allowed, no error, right? No error. Okay. Now, suppose if tuple is immutable in Python, and suppose you are creating a tuple, right? In your code, once you are creating a tuple and you are storing 1, 2, 3, and instead of 4, you have stored -1 there, right? It is a mistake. Okay. So how to correct that one? How to exactly change a value of in a tuple? We can do that. We can change a value of a tuple, not exactly the tuple, but we can uh, solve this particular type of scenario, right? So how we can achieve that? First of all, we cannot change the value of exactly the value of a tuple. So first of all, let's convert this tuple to a list. Okay, convert this tuple to a list. We can do this type of conversions. Right, we have seen that how to convert integer to float, float to integer, and all that. So we can also convert a tuple to a list. Let's print my list. See, this is a tuple, this is a list. Okay. Now We are free to change the values of a list, right? Let's change the value of list. My list index number. Let's go with negative indexing. Python also supports negative indexing also, right? So instead of -1, we have 4 there. Now, what is minus indexing? So we have seen that we can provide indexing from 0, 1, 2, 3, right? But there is one more type of indexing which start from the last. It is -1, -2, -3, -4. Right? If I will try to print, if I will try to print my tuple -1, it will print the last element. If I will try to print my tuple -3, it will print the last element from the third, right? Last element from the third. So in this case, we got -1, the last element. In -3, the third element from the last, that will be 2. So we are getting 2. So this is a concept of negative indexing only supported by Python. You cannot say use negative indexing in Java or in C++ or in C. Okay, so we have to change the value. Yeah, we have to update the value, right? So the value of list is updated. Now, if I will try to print the list, the value of -1 is updated to 4. Now, what we will do, we will again convert this list to a tuple, and we will print tuple. Wait. So we have successfully changed the value of a tuple, right? By converting that tuple to a list, then list back to tuple. Okay. Now this my tuple variable and this my tuple variable are completely two different variables. Memory location of this one and memory location of this one may or may not be same. It is not guaranteed that memory location will be same, right? Both the memory locations are different. What happened just right now? We have created a new list, my list, using a tuple by using type conversion. We have done some operation. Then we have created a new tuple. We have created a new tuple, right? And why I am using the same variable name? So I have to override this particular value, right? If I will use my tuple 2, then in my code, there exists a my tuple variable, right? With the incorrect values. So to cover that one, I use the same variable name. So this will be deleted. A new tuple will be created from the correct list, right? And we got the value. Okay. So this is how you can change a value of a tuple. Not exactly a tuple. This is how you can create a new tuple with correct values. So guys, any questions till now or any doubts from yesterday's class? Okay. Let's move to dictionary. And again, it is a new data type. Okay. Up till now, whatever type of data type we have seen, they support indexing. Right? Okay. One more thing, how to iterate over the tuple. So use for loop for each loop. My tuple and print each element. One inverted and both comma. Right. Instead of space, I provided comma. So in between every print, we will get a comma. Right? Now dictionary. So dictionary doesn't support indexing. Okay. How a dictionary is stored? So first of all, if you want to create a dictionary, there are two ways to create an empty dictionary. First one, the second way by using text. If I will print the type of my dictionary will be dictionary. Okay. Now, dictionary stores data in a key value format. Right. Now, what is this key value format? If I will create a dictionary, I have to insert data in the form of key, colon, and value, comma, 2 colon 8. 2 is my key, 8 is my value. Okay. A is my key, 5 is my value. Right. Again, let's take 17.8 as my key and true as my value. Okay. Just a good practice, guys. Please don't provide a float as a key. In any programming language you are working, don't use float as a key. In this case, it is an example, so it's just use this one. But whenever you are uh, completing a project or just programming in any language, don't use float as a keyword. Because see, our system, every system can represent an integer, complete integer, right? Every system can represent 2, 10, 10 to the power 9, 10 to the power 100, all these numbers. But can exactly represent a float in binary format. You cannot exactly represent a float in binary format. Exact value. Okay. Leave that one. So see, if I want to print a particular value, if I want to print a particular value, I have to use key to get that value. So if this is my key, the value is this particular value. After colon, I have the value, right? If I will pass 2 as the key, then 8 is my value. So instead of indexing, we can access each and every element of a dictionary using key, right? Instead of indexing, we uses key. Now let's try 17.8 and that will give true. Now there are certain rules to create a key and to create a value. So from the above example, you can see that we can create a string as a key, we can create an integer as a key, we can create a float as a key, right? So like we cannot create a list as a key. It is not allowed. Suppose this is my key and this 13 is my value associated with that key. See, I will get an error, but I can use tuple as a key. I can use tuple as a key and no problem with that. If I want to print the value of this tuple, see, I will get 13. So there are some restrictions. First of all, let's discuss the properties of a key. So keys should be unique. In a dictionary, keys should be unique. If suppose I will create another key 2. See, I have a key 2, right? but I will again create a key 2 with value 800, right? See what I will get here, 800, not this 8, this 2 8, this particular key value pair was deleted. You can say that it is overwritten, right? Overridden. So never use duplicate keys. Okay, so make sure there are always unique keys, right? Okay, only immutable data types can be your key, right? So tuple is mutable. We cannot create tuple as a key. That's why always immutable data types will be your key, right? And values can be any value, any data type can be a value. No, think of this. Can true be a key or not? Is it legal? Is it allowed? When we create a key with true, okay? Because we have never discussed about boolean. Booleans are mutable or not, right? See, yes, true is allowed as a key, okay? And from here you can state that boolean is an immutable data type. Boolean can also we know that Boolean can hold only two values, either true or false at a time. So it is immutable in nature. Right? There is no append or something like that for a Boolean. Okay. So true is allowed. We have seen that list is not allowed as a key, and there is no indexing. There is no indexing in particular dictionary. Suppose if I will say that I want to print my dictionary index number 0, right? My dictionary index number 0, which is supposed to be true one. I want to print this, my dictionary index number 0, right? See what I will get. I will get a key error. The name of the error is key error. It states that this 0 as a key is not found in your dictionary. Right? This is a key error. Okay. Yeah. Okay. Let's see the memory representation of this one. And dictionary is in itself a mutable data type. Okay. So if it is a mutable data type, it supports copy, deep copy. There is some similar method as append in list, right? So there are some similar methods in dictionary also. This is the memory representation of dictionary. A table of keys, a table of values pointing to some particular values. Right? It is a little bit complicated. Take smaller examples. See, it is again not clearly visible. See, this dictionary table is divided into two columns, right? Okay, the first column holds the key, the second column always holds the value. This 2 is our key, this 8 is our value for that 2. See, 2 is our key, 2 is our key, and 8 is its value, right? Then we have A as our key, 5 as its value, 17.8 as key, 2 as its value, right? Now, let's discuss about different types of methods in dictionary. Let's create a dictionary with some basic values. Let's map a string. Okay. Now E is equal to 20 plus my dictionary C. Okay. Take a guess what will be the exam answer. It will throw an error or I will get some answer here. Okay. We will get the particular 23 as our answer. 20 we have provided my dictionary 3 will result in the value of 3. My dictionary C will result in a value of 3, right? Okay. See, we have seen that if I will create a particular list with some values and if I will perform some addition operation on any particular list variable at index, suppose index 3. So 4 is at index 3. I will get the second answer this as 24, right? So I'm getting that as 24. This will result in 4, right? Similarly, this will result in 3. Okay. Now let's work with the different methods here. Okay. Now how to iterate over a dictionary? First, for each loop for element in my dictionary, print element. Observe where we are getting only the key. There is no value. We are only getting the keys, right? When you use for each loop for a dictionary, you always get only the keys, right? If you want to access the elements for element in change those to for element in my dictionary dot values. In this case, for this particular, let's use some good formatting here. Yeah. So for this first for loop, we only got the keys. When we use dot values with a dictionary, the dot values with a dictionary, we only get the values, right? Okay. Suppose you want to print, suppose you want to print both the key value pair, both the key and value pair together, right? For that, use for eval in dictionary dot items print eval. Okay. In this case, we are getting the key value pair. Guys, clearly observe one thing. The key value pair is returned as a tuple, not as a list or some integer or string. No. Key value pair together, they are returned as a tuple, right? So if I will print the type of key value, we will get tuple. See the type of this particular tuple, right? Now there is one more uh, iteration can do. Right? I mean that is not that necessary, but you can perform that also. You can use dot keys to access the key only the keys. Right? See, this will again only give you the key of the dictionary, right? Now, what if You want to access a particular key and a particular value separately, but only in a single for loop. Your task is to implement a single for loop, only one for loop, to separately access a list, sorry, the key and the value, right? So this will be a new concept, right? There is some particular concept in Python popularly known as tuple unpacking, right? Tuple unpacking. Suppose I have a tuple with values 1 to 3 and fruit. It's taken me. Okay. And if I will do this, it won't throw any error, right? And if I will print A, it will give me 1 as an integer, not as a tuple. If I will print the value of C, it will give me a particularly Boolean value true, not a tuple. This is known as tuple unpacking. Each and every value of a tuple from the right hand side of the assignment operator is given to the each and every variable to the left hand side. If I will remove C from here, in this case we will get an error, and the error says that are not enough values to unpack. I mean, no enough variables to unpack, right? Too much values inside tuple and the number of variables are less, right? So instead of creating a tuple variable, you can do this. Both are same, no difference. Okay. Now the same concept goes here. Okay, so what is this key value? Key value is a tuple. I will create a key, comma value is equal to key value, right? And let's print it using some formatting. So key colon value. Let's print it. See, this is how we get the output, right? We have extracted that particular key and that particular value from inside the tuple, right? This is tuple unpacking. Okay, we are performing tuple unpacking, right? We can again achieve this in some other way, something like this. You can do this like index 0, then again index 1, and it is again valid. No problem with that. Right? But there is some concept of tuple unpacking. Okay, so this is one of the way. Another way we have, instead of performing tuple unpacking inside the for loop, right? Inside the for loop, perform tuple unpacking just here in your variable. What this my dictionary dot items will give you, it will give you one single tuple at a time, right? One single tuple at a time. This key value pair at a time. So this is given to you at the point. This is given to you. Convert that or unpack that tuple to a key value, right? And this will again result to the same output. No error or nothing else is there, right? So instead of performing tuple unpacking inside the for loop, perform tuple unpacking here itself. Okay. So these are different types of for loops you can operate with dictionary. Okay. Now, let's work with dictionary functions. We have different types of functions with dictionary. Take this one away. So there is no count function in dictionary, right? First of all, we have seen that if I will try to print my dictionary, suppose key 1. Key 1 doesn't exist inside my dictionary. It will throw me an error, key error, right? Let's see about get. Bit variable dot get. And inside this get, you will pass a key. See, if I will perform this, if I will try to get a key using get, what happens? I won't get any error. Both are same thing. It will this get will return me the particular value. See the particular value of a key, right? So it is safe to use get as compared to square brackets, right? If the key doesn't exist in your dictionary, you will get none as your output, right? Now suppose instead of none, I want something else, right? Instead of none, I want something else. I want to print a message that doesn't exist, right? So it will print key doesn't exist. Other than that, we have a message, right? This particular message is known as default value. Now, what is a default value? So if the key is not present in your dictionary, the get method, this get will give you the default value, right? So it is a very good method, always used to return 0 as a standard procedure with get, right? As standard practice. So it will tell you that there is no dictionary, sorry, no key or no occurrence of that key, right? Okay. Check. We have seen get, right? We have seen keys, items, and values. Yeah, so pop is similar here. Pop, right? Now, guys, let me know, just think of a situation why we are getting this error. Why we are getting this error with pop? See, we have seen this particular syntax for pop in list, right? We have seen that pop is used to delete the last element. But why we are getting an error? Okay, so we have seen the memory representation of dictionary, right? So how does the compiler know which particular element is your first element and which particular element is your last element? Yeah, key value for dictionary, that's good. See, by seeing the memory representation, you cannot say that this particular value, this particular value is your first value, or this particular last one, this is your last value. You cannot say that, right? Because this dictionary doesn't support indexing. if a data type is not support indexing, you cannot define which particular value is first value and which particular value is last value, right? So pop is supposed to delete if we don't provide any value inside pop. Pop is supposed to delete the last element. But in dictionary, you cannot determine which is last element and which is first element. So there is only one syntax of pop which operates in dictionary. Dictionary variable dot pop, and inside pop we pass a key, right? Suppose if I will pass C, right? This will delete the C and we have the remaining variable. I mean the remaining key value pairs. If I will provide some other key which doesn't exist inside your dictionary, in that case we will again get a key error. Always try to remember the name of these errors, right? So we will get a key error. Instead of C, let's delete. Okay, let's delete C. Now we have seen pop update. Now I have a dictionary. I have the second dictionary with some values like A with value 90, 6 with value 98, and I want to concatenate both of them into dictionary 3. And we will get a error again. Okay. Now concatenation of two dictionaries are not allowed. Now, what is the case? Why don't it is allowed, right? Why we cannot concatenate two dictionaries? See, first of all, in our dictionary 1, we have a key value pair A1. In our dictionary 2, we have again a key value pair A90. So suppose if both the dictionaries were concatenated, then inside the final dictionary, there will be a key as A. Then what will be the value of this A, 90 or 1? That you cannot determine that what will be the value of this A, 90 or 1. So due to the potential clash between keys and value pair, key value pair, dictionary concatenation is not allowed. Right. Now there is some other methods also present here to concatenate or to insert two different dictionary inside another dictionary, that is known as update. Okay, let me first create a my dictionary 3. Let's update this one. Dot update. First of all, let's insert my dictionary. Okay. Now, if you only want to, insert only single dictionary, you can achieve that by using copy or deep copy, right? So I'm not going to discuss copy and deep copy with dictionary. We have seen the problem why mutable data types have the memory management problem, and we used copy and deep copy in those cases. Okay. Here, if I will print my dictionary 3, okay. So see, my dictionary, so my dictionary variable is inserted inside my dictionary 3, right? And observe the key value pair A1. Observe this one. I'll copy this. Let's insert 2. Now see, I have inserted 2. Okay. So what it will do, it will override the classing key, the potential class between the same keys, right? Your my dictionary 2 is holding a key A, your my dictionary is also holding a key A. So whichever is the latest one, whichever is inserted, okay, the last, that overrides the key value pair. Okay, and see the new key value pair is inserted here. This is another key value pair. So let me take 1 minute to map to some value 1. See, so that is also inserted. No problem. By using update, you can insert a single key value pair like this. So this is my new key and this is my new value, suppose bread. Okay. And let me print with my dictionary. See, a new key value pair is inserted, and you cannot say that update inserts the key value pair at the end of the dictionary. No, you cannot determine the beginning and the end of a dictionary. Okay. So we have seen get, update, pop, set default, pop item, create. Now there is something known as set default. Now suppose see, I have I have no key with value 6, right? Inside dictionary there is no key with 6. 6, we have no 6 key. Okay. So for this 6, I am passing 90. Let's print the dictionary again. See what it will do. If the key is not present inside your dictionary, it will insert a key with the default value you have provided. It will insert the key with the default value you have provided, right? Okay. Now the correct syntax of using this one is inside print statement, because this particular function also returns something. It returns the default value. Okay. So instead of this one, let's use a variable here to store that return value, right? If the particular key is not present inside your dictionary, it will perform two operations. It will insert the key value pair and it will return the default value to you, right? Now if the key is present inside your dictionary, suppose I have a key B, right? And let's take the default as I will send it. See, no value is inserted, no new value is inserted. Why? Because the key is present inside my dictionary, and what this set default has written, what this set default has given you, it has given you the particular value associated with that key, right? So there are two scenarios of using set default. Okay. First one, if the key is not there, it will insert the key and the default value as your key value pair. If the key is present there, it will simply return you the particular value associated with that key. Okay. Now pop item clear and delete. Guys, we have seen that you can use my dictionary dot clear to clear the to delete each and every value. Right? Now guys, observe there, after clearing each and every value, the variable my dictionary exists. Variable name my dictionary exists. But if I will perform del my dictionary, this is a syntax of deleting a particular variable. And after this, if I will print my dictionary, see what I will get. I will get the error, and the error is my dictionary does not define, is not there. The complete variable my dictionary is deleted. There is a difference between only deleting the value and deleting the complete variable. See, if I will perform my dictionary dot here and delete created my dictionary with a clear, after clearing the memory, the clearing each and every value, the my dictionary variable exists in the memory, right? This my dictionary variable is there. But if I will call this delete, if I will do this delete, the my dictionary variable itself is deleted, right? The variable itself will be deleted. So now I'm going to call this particular red line defines, which is the next statement to be executed. I'm going to delete my dictionary variable itself. See, if I will delete the my dictionary variable itself, the variable is gone, right? So be aware of this one, right? Now, guys, let's take a 2 minute break. Okay. And if you are having any doubts, put that in the comment. Can we access the value by giving a particular key? Yes, we can access a value by giving a particular key. See, here we are accessing a value by giving a particular key. 2 is the key and we get the value 8. Right. 17.8 is our key and true is our value. We are getting the value. And if you want to update a value, you can do that. My dictionary 17.8 instead of true. Here I want some string, right? Right. So the value will change, and if you want to, if you will print the whole dictionary, the value will be updated there. See, 17.8, the new string is there, right? This particular inside the square brackets, these are key only, and by using the key inside square brackets, we are getting the value. And instead of square brackets, I will suggest use get. It is a more safer option. If the key doesn't exist, we won't get any error in this case. Right. Okay. I think I cleared your doubt and there are no questions. So let's move to conditions. Now guys, from Okay. So from this point onwards, we are really going to understand how a Python code works. Up till now, we are only discussing about different types of variables and different pitfalls and errors and all those things. From now, we will discuss about how Python code works. Okay, so suppose this is a Python file, .py file. You have written some particular codes here. You will interpret it with, first of all, compile a Python is interpreted and compiled both, right? It is, you cannot say that, yes, you can state that Python is an interpreted language, but at some point, Python is also a compiled language. So this statement is in itself, it's a confusing statement, so leave that one. So this particular Python file is executed in your system, right? And you will get some output, some result. Okay. Now suppose I have some one more Python file and it again works with some particular values, some values, some dictionary or some other values, some list or some dictionaries or some values, and it will again generate some output, right? Then again, I have one more Python file, the Python script or Python file, whatever that is, Python source file, and it will again work with, suppose in this case, it is working with a tuple. I mean, performing some operation on a tuple given by user, right? And provide you some output. Now, instead of these three different Python files, right? Instead of these three different Python files, we can perform all this operation in one single Python file, one single Python script. Now, what is a function? A function is a block of code. A function is a block of code which performs some in which takes some input, which may take some input, may provide some output on that input and perform some operation inside it. Right? User will provide some input, it will perform some operation on that input, and then after that it will provide some output. This is the main role of a function. What is function? A block of code which may accept an input and perform some operation on that and provides an output. What is the need of a function? Okay, so consider a scenario. Suppose this is our problem statement, right? We have to take five lists of four element each from the user, increment each element of the list by some value. Okay, so let's first of all create this code. I'm going to need n is supposed to be 4. Then we have to take four elements. We have to take four elements. Instead of implementing it by 20, we have to take a user input. So let's take a user input. Now, this is to perform for one single list, right? I want to repeat this again and again for five lists. Okay, so this code is to perform some operation on 5 different lists, right? I'm not going to execute this one, it will take some time. So, okay, guys, so notice one thing, we are again and again performing some repetitive task, right? What is our task? So we have to, this particular code is performing our task, right? And we have to repeat this code 5 times or 10 times or 15 times, whatever is the requirement, right? So if I will put this code inside a function, right? And instead of writing that code again and again, I will provide different inputs, and on different inputs, the same code will run and it will provide me different outputs. This is the main use or motive of a function. Function is used to implement repetitive tasks. Right? Functions are used to implement repetitive tasks. Now, how to create a function? So let's first start with some basics. So this is a syntax to create a function. Def keyword, def is the keyword, your function name, small brackets, and after that a colon. And here you will write your code. A is equal to 10, B is equal to 20, print A, print B. This function name can be anything as you want. Now, this is a function. I have said that the function may accept some input and may provide some output. May. It is not compulsory, right? So first of all, let's see how to execute a function. How to execute a particular function. So for execution, you have to call that function. Function call. Okay. Now how to call this function? Just provide the function name, curly braces, and this will do the job. It will call that function. So if I will call this function, what happens? A 10 will be created, B 20 will be created, A and B will be printed, and the program ends. Right. Let's take a bit of memory. Now, as I have told you that function is a block of code. So that block of code also takes some memory to store. Right. See, this is the function. This function takes some memory. It's taking some memory, and this code is written inside that memory. Okay. Now we are performing a function call. See, we are not inside a function now. As the functions are is written in line number 2, 3, 4, 6, we are not inside the function right now. We will go inside the function once there is a function call. So see, there is a function call. Now we will go back to function. See, we are now inside the function. After a function call, we are inside the function. A variable A will be created. See, a variable A will be created. Because notice one thing, there is two memory blocks, this one and this one. Okay. Now, why two memory blocks? So guys, whenever we are executing a function itself execute in a separate memory other than your program. This is known as your global memory, and this is your function memory, your stack memory. This is known as stack memory, where a function is executing. This is particularly known as stack memory. Now, A will be created, B will be created, print A, print B. See, now after line number 5, they just right now ignore this return value. After line number 5, I am going back to line number 8. After line number 5, I'm going back to line number 8. See, we will go inside a function when we receive a function call. After completing that function, after executing that function, we will come back to the function call. right? After completing that function, we will come back to the function call. Now, see, this one is faded. Our program, the execution of program ends, right? This one is faded. Why this one is faded? Because once you exit a function, the separate memory, that stack memory allocated to that function, given to that function, was deleted. This particular memory was deleted once the function call is completed. Okay. Now, as I have told you that a function may return some output and may receive some input. So there are a total of 4 type of functions, which input, sorry, without input, without output, which is typically known as the particular technical term for an input is argument, with argument, and the output, the technical term for output is return. So there are total of 4 types of functions: no return type, no argument, with return type, no argument, and no return type with argument, and with return type with argument. Total of 4 values. This particular one, there is no, we are not providing any input. We are not providing any arguments. And this function itself is not returning a value. It is printing something, it is doing some operation, but it is not returning you a particular value. But it is not returning a value. So that's why it comes under the type, no return type, no. Okay, so are we okay with this concept? Is there any doubt up till now about function and why we use function, how function is executed? Function will be executed by using function call. A function will get its own memory for execution. After the execution of a function is completed, that particular memory will be deleted on its own by Python, right? There is no, the user is the user intervention is not required there to delete that particular memory. Well, let's see some different variations of function. Now, how to receive an input and how to provide an output using a function. Suppose a very basic example. I have a function name as some integer, and I'm going to receive 2 different variables, A and B. What is my job? I have to perform the addition operation and I have to return the value, right? Now, this particular A and B, these are known as formal parameters. Now, there is a change in function call. Also, this say, this particular one is known as return statement. There's a slight change in function call. Now, we have to provide some inputs to this function, right? So for that, the function call will be this 10 comma 20, right? So this is a function call where we are providing some input. Now guys, why 10 20 and why not only 10 or only 20? Right? Why? Because it is expecting, this function is expecting us to provide 2 inputs, input A and input B, right? That's why we are providing 10 and 20. Now see how this memory will work. See, here a function was created in the memory. This is the function memory. A function was created in the memory. We are calling that function with 10 and 20. See the function call. 10 is given to A. 10 is assigned to A. 20 is assigned to B by itself. There is no user intervention here. I have not done anything. I have just provided the value. Python compiler, the Python interpreter, has assigned 10 to A from left to right. Right? The values were assigned from left to right. 10 to A, 20 to B. If there will be some C, then the next value to C, next value to D, something like that. Okay. Inside this, a C is created and A plus B is performed there. Right? See the return value, what we are returning C, and C is nothing but this memory location. So we are returning some value back. Like after performing some operation, this particular function is returning some value. Okay. Now we come back to this function and our codes end. Now guys, this is not a very good example of using you can say with return type and with argument function. Now see, we have seen that that function is returning us some result, right? So let's create a variable to store that result. See, we have seen that whenever a function call end, it will return back to the line where the function call was made, right? If the line 8, from line 8 a function call is there, after executing the function, we will come back to line number 8, right? And the value, the return value will be saved inside result. And let's print this result. See, there is no result variable created up till now. We are now inside function. First, the function call was made. See, this is a typical use of assignment operator. This equal to sign assignment operator. It always works right to left. First, it will do the right operation and insert that value to left. Okay. So in right, it got a function call. So we went for a function call. No memory for result was created up till now. Let us see, add the value, return the value. Now see, after the execution complete, we will come back to line number 8 and result is created. A result, particular result is created and we are printing the result. See, we got the output as 30. Now, suppose this is not a very good example up till now. Let's make the use of function. So the sole motive of using a function is to implement a code and use that again and again, right? So let's again use this code with some different values like 100, 200, and again use this particular function with values like -10 and 20.6, right? See, let's come to first call, execute with value 10, 20. C will be 30, it will return 30, 30 will be saved to result. Now after this line number 11, we are again calling the function but with different values. See, again, see this particular reason, this particular memory was deleted, right? This memory doesn't exist anymore. In this visualization, we are having the memory is there, but in reality, the memory delete. It is a stack memory. It will be deleted once the function call will be completed. Then again, A and B will be 200. Sum up to 300. Again, one more result will be created. The same result variable. I have not created a new result variable. Now the same result variable is pointing to 300. I mean the value of that result variable is 300. We got 300 as output. Again, we call the function this time with different values. See, this time the function is called with different values. Right? Both this memory, and this one memory, both of these memories are deleted. Okay. Then again sum up some values, return that value to z. That's it. Okay. And we have a very large value here and the code ends. Yeah, guys. So I was discussing about why not to create a float as a key, right? A key in dictionary. Why not to create a float as a key in dictionary? See, the float value is 10.6, and the exact value of this operation, adding 20 and minus 10, should be 10.6. But see how that float value is represented by Python. That particular float value is represented as and end with 1. Okay. So always take care of the situation whenever you are comparing two float values. If I will compare 10.6 is double equal to 10.600001, it may gives you a true condition, it may give you a false, right? So be aware of these situations. Okay? Yeah, so we have seen function calls also. Now let's implement our task. So let's create a function, and what we have to perform, we have to increment, right? So let's name it increment, and we are expecting a list, so name it my list. Paste the code here. See, indentation is everything in Python, right? There are no curly braces or anything. So indentation is here. Always indentate your code, provide indentation for your code. Right? This particular block of code is inside my function. Now I am exiting the function. So now I am outside the function. Now let's make a good use of this function and return the particular updated list. Right? Okay. So we have to do this operation 5 times, right? We have to do this operation 5 times. First, call the increment with, okay, so let's not provide any value here because we are taking the list inside the function, so no need to provide the list. Right. Let's perform my list 2. Three, 4, and 5. Okay. Only this much code is enough to execute this function again and again. Now consider the first scenario where we have to write this 5 or 10 lines of code. For 5 iterations, we have to repeat this 10 lines of code for 50 times, right? But for a function, just put that code inside a function and call that function 5 times or 500 times as you need. Okay. Now, so if we will perform this, we'll ask for some inputs. So let's use script. So I'm going to perform this only for 2 lists, right? Let's print the value of this list. Now we are inside this particular function, and this particular function is asking me for some input. So let's first do some formatting. About some value. Put this element. Okay. So it is asking me for some value. So let's increment this one by 12. First list element 1, 2, 3, 4. Right? You can get the particular expected answer. It is 210, 400. Okay, guys. So in this case, we have inserted the first list as 1, 2, 3, 4, and we have to increment each and every element by 12, right? So instead of 13, 14, and 15, I got 5, 6, 7, 8, right? Let's see why. The variable names are same. Instead of A, I have to use something else. See, the variable name of this A and this A were same, right? So that's why when we visit here, the last value of A, the last value that was we have inserted 400. This 400 was used for incrementing. Yeah, we can call a function within a loop. For this same problem, we will see that this one. Well, 1, 2, 3, 4. Now we are getting the correct values. Okay. Now let's use this one. Here we have. Yeah, so the same thing will go there. See, this this particular value, I mean this particular variable and this particular variable are exactly same, right? So that's why we are getting an error. I mean a logical error, not a compile time error, a logical error in doing this addition. Let's change the name. Okay. Now, instead of calling these many times, suppose if the scenario we have to call this function 500 times, how we will do that? So yes, we can use a for loop in range 0 to 5, and inside this you can call the function and you can print, right? This 5 calls or the 5 call which is going to be created here inside for loop are identical, exactly same. There is no logical or any implementation difference, right? Only the syntax are different. You can do either this way or this way. Okay. Yeah, there are only three types of loop: for loop, while loop, or do while. So you can call a function. See, you can call a function everywhere in your Python code. Just make sure. See, if I will provide a function call, I will provide a function call just above the function. In this case, I will get an error. Okay, and let me show you why. See, see guys, right? We are at line number 1, and we got a memory for A, B, and C. See, up till line number 7, our function is not defined. The memory to that function, we have not created a function up till line number 7. So before line number 7, we cannot create a function call. We can call a particular function until unless we have created that function, right? So up till line number 7, the function sum integer is not created. So we cannot provide a function call at some line number 5 or line number 4. It will throw an error. Difference between keyword and position. We will see the difference keyword and positional arguments. So always try to uh, provide a function call after the function declaration, right? This particular thing, this particular whole block is known as function definition. A function name with function code. See, the function name is increment, and here is the function code. This whole block is known as function definition. Okay, so I'm not going to execute this one, it will take much time, right? Okay. Now, so come back to our sum function. Suppose we have to sum three elements, right? So we have to add the values and we have to return this result, right? Now, let's call this particular function with some values. Say with A and B. So we are good with this. There are some formal parameters. This particular 10, 90, and 80, these are known as arguments. The values we are passing to that function, this is known as arguments. Right? Now, well, suppose as a user, you want to add three integers, right? Okay. But suppose there is some other user and he wants to add only two integers, integer 90 and integer 60. And he wants to use this same function for that. Okay, so there is a concept of default parameters. Now what is a default parameter? So see, let's first see the syntax. So I will provide c equal to 0. This c is known as default parameter. Okay, a and b are not. C is known as default parameter. Okay, now guys, if the user does not provide any value to a default C, I have told you that whenever we will provide the values, it will be assigned from left to right, right? So this 90 will be assigned to A, this 60 will be assigned to B, and we have not provided any value for C. So if the user does not provide any value for a default parameter, we don't get any error, right? So I will do this and we won't get any error, and there are some outputs. But if I will remove the default parameter, now these are actual parameters, we will get an error, and the error is few arguments were delivered, missing one more required argument. We have to provide required argument there, right? So yeah, so this particular C, A, B, C are known as positional arguments, right? Yeah, you have to provide default. If you are creating a function with the default parameters, you have to provide value in function definition only, right? Also inside the actual parameter values, inside these small brackets, not inside here. I cannot do this and I will suppose think like that. Now C is my default parameter. No, you have to provide in the actual parameters here, right? Now C is considered as a default parameter. Okay. Now see, let's see how this works. Okay. One keyword, one key definition for a default parameter. If the user does not provide any value for a parameter in a function, then the default value will be used. So, see guys, this is how a default parameter will be created. We just leave this memory implementation of default parameter for now. Okay. For ABC, we have created some value. So 10, 90, and 80 is there. Always remember the rule. Value will be inserted from left to right. 10 to A, 90 to B, 80 to C. Okay. So user have provided some value for C, right? So C is considering 80. and it will return the sum of three elements, and we got some value. That's good. Now we are calling the again the same function, but we have not provided any value for C. In this case, C is having the default value, the default parameter value we have provided there. You will provide 0, 10, 20, whatever you want, just provide there, right? So if I will provide C equal to 0, then this function is again able to perform some the calculation, the sum of two integers. Right? You perform the sum, return the value to the variable b. Perform the sum, return the value to variable b. Again, see, Python manages memory very efficiently. So this 90 was given to A, right, to save memory. There is nothing else other than save memory. No more logic than other than saving memory, right? This A, this particular A, this A inside this sum, and this A are two different elements, right? Two different variables inside two different memory. Actual parameters and formal parameters. See, this parameters here, this particular parameters in your function definition, these are known as formal parameters. Okay, and the argument I am talking about, these particular values, this argument, this is also known as your actual parameters. Right, these are just keyword names, or you can say technical names. You can use one or other. Right? So your attribute is known as actual parameters, and your parameters in your function definition can be also known as formal parameters. Just naming convention, no other than that. Okay, so we have seen that default parameter. Right? Now, see, there is a pitfall here, right? Error-prone condition. If I will provide default for this b is equal to 0, we will get an error. It is mandatory to provide or to write the default parameter at the end of the parameter list. This is our parameter list, number of parameters we are expecting. So we have always write the default parameter at the end. Suppose I have two default parameters, b and c, or suppose I will create a d also, right? And I will now this function is able to create return the sum of four integers, right? It can also return the sum of two integers, three integers, or four integers. Suppose let's call the function is four integers. Take the value as 10, 20, 30, and 40. Print C, right? So this is going to call this particular function with four values, and it will return the sum of four values. It will return the sum of two values. It will return the sum of three values. Right? So it is mandatory to write or to provide the default parameters or default values from right to left direction. And why this? So let's talk about some logical explanation. Suppose I have provided 10, 90, and 80. And what I am expecting that this 10 will go to A, this 9, sorry, this 90 will be go to B, and this 80 will be go to D. Right? We are expecting that, right? But this is not the case. The assignment of the values always go from left to right. 10 for A, 90 for B, and 80 for C. And we won't provide any value for D. So we have always have to provide the default values to the last element, or you have to write the default parameters in the last. See, we have seen that the similar situation right now. If you will provide, if the user is providing the value, the user provided value is giving the priority. The function call will give the priority to the value provided by user. See, this C, in this case, this C is having the default value 0, right? But the user is providing 80 in this case, line number 5. So the value of C is 80. The function call always give priority to the user the values the arguments provided by the user. Okay. The definition of the default argument is itself, if the user does not provide the value, use the default arguments. Okay. So these are default arguments. Now there is one specific thing in Python only introduced in Python, not in C. This this function called default parameters and actual parameter, all these things exist in each and every language, right? But there is some special things in Python, which is known as keyword argument function call. It is just a very big name, nothing else is here. So suppose I want to provide some targeted value. I don't want to follow the convention that the left value will be given to A, the 90 will be given to B. I don't want to follow that. I want to provide specific value as I want, right? Yeah, we are just going to see that one. So suppose I want to call B with value 55, A with value 4, and C with value 38. And this is a valid function call. And you are defining that which value is given to which parameter in your function, right? Let's see the memory representation, the visualization, and it will be easy to understand. Some function which do default arguments, default parameters. See, it is using the name default argument. Again, this particular, these particular parameters, formal parameters are referenced as arguments here. So these are only the keywords. Okay. You can use anything in whatever you want. So see, we have provided some targeted value to C. So instead of the default value, it is using the value provided by the user. Now guys, here the rule, the left value will be assigned to the leftmost parameter is not followed, right? We have targeted that the value 55 should go to B. So the value 55 is there with B. We have targeted that value 4 will go to A. So the A is having value 4, right? So this type of function call is known as keyword argument function call. Keyword argument function call. You can do one more thing. Suppose instead of uh, BD, just provide D equal to 10 in the starting. Then this will be again good to go, right? Because we are not providing D to 10. So the D is taking its default value 0, right? Okay. Any more queries, any more questions? Okay, now let's discuss about some good practices with uh, particular functions, creating a function. Always use keyword function calls. Never use this type of function call in Python. Okay. Always write your default parameters the rightmost uh, at the end of your parameter list. Now, guys, we have discussed that defining the data type for a particular variable is doesn't put any significant impact in Python, right? But it is a very good practice to provide this type of implementation. Right? We have talked about documentation, so this is good for your documentation, right? Now, again, this function is returning a result, right? So for return type, you can use arrow and then write the return type. The return type is int. We are expecting to get these many types of integer, and this function is returning an integer. But again, it is not bound to return integer. You can return a string also. No worries with that. We can do this and it will print hello. So always try to, at least if you are not writing the data type, the expected data type for each and every parameter, just write the data type for a return type. Okay. If suppose that this one is returning a list, so I will write list. If this function is returning an integer, I will write. This function is returning nothing, so I will write null. It is not taking null. Oh, sorry, there is no null. It is none. So null is a keyword defined for Java and Python, sorry, C++ and Java and C. But in Python, the same that null is known as none. Both are same, null and none are same. So what is null? So null means nothing. Nothing is not even a value, a data type, nothing. Null means exactly void, exactly empty space, nothing, vacuum, something like that. Null means nothing. Okay. Now let's talk about predefined functions and user defined functions. So whatever function we have created here, some integer or increment or this function name, whatever these functions are or your list increment, all are user defined function. We have created that function, right? But from day one, we were using print, and print is again a function, right? And it is a predefined function defined by Python. Press Control, hover over it, and you will go to the implementation of print. Let's go to the implementation of print. See, this is the implementation of print, and all of these are the different types of actual parameters, sorry, formal parameters print is expecting us to provide. First one is object and whatever that is, and there are some uh, default values are provided. We have used end, right? The default value for end is next line. So that's why if you don't provide any end, the particular print statement will print the next line, sorry, the next string in the next line. Right? There are some other file flush. These are some, you can say flush is an advanced concept. Okay, file is used for file streaming when you will work with files in Python. Right? So print is a predefined function. Again, we have used sum, right? Suppose I have a list value 1 to 3, and we have used sum to add this list, right? This sum is again a predefined function. This sum is again a predefined function. And see, I have told you that sum can provide you a sum of any type of iterable. So see, it is expecting an iterable. See, this is a good practice of providing documentation like this. So by seeing this particular data type, you can say that the first parameter should be a iterable. The second parameter should be an integer. Okay, guys. So I think that's it for today. From tomorrow, we will discuss about OOPS concept, object-oriented programming. So up till now, whatever we have discussed, just go through that. And if you are having any doubt, we will first for tomorrow's session we will clear the doubts, and after that we will start with the OOPS class and objects. Right?